Yeah. Hi, Kashif, can you hear me? All right. So, you're welcome. Guys, you're welcome to the second session where we're going to be taking a deep dive into Xend Finance SDK and how to integrate Xend Finance SDK into your dApps. So, we have Kashif in this session, and he's actually a blockchain engineer at Xend Finance, and he's going to be taking us through how to integrate the Xend Finance SDK and also the L2 protocol in our dApps. So uh, I'll just bring Kashif up on stage, and he's just going to start right away. So, hey Kashim, can you hear me?
Hi, Ushay, can you hear me? Can you see me?
No, I cannot see you for some reason, but I can hear you.
1 second. Just having some trouble with my camera.
Okay.
Okay,
Cool. Yeah.
here we go.
So, yeah. Thank you so much,
Pleasure,
Kashif.
man.
Yeah, welcome, man. So, I've done the introduction. You can go ahead and just introduce yourself and get right on into today's session. Yeah.
Hi, guys. My name's Kashif K. Albertus. I'm a full stack block engineer at Xend Finance. And, I have the pleasure of taking you through a few things today. Some of what includes the SDK integration, as well as some other features using Web3 that I wanted to just take everyone through. So if I may begin, Ushay, can I jump right in? We've got quite a bit to cover.
Yeah, sure. You can jump right in. Thank you.
Okay. Okay, please confirm you guys can see my screen.
No, I don't think I can see your screen. Okay.
1 second, let me just reshare.
All right. Okay, cool. I can see your screen now.
Okay, cool, fantastic. I think let's jump right in. What I've done is I've actually built sort of a little demo Dapp UI to take everyone through some of the features one can achieve with Web3. And of course, more importantly, what can we achieve with the Xend Finance SDK? So I'm going to jump right in. As you can see on the screen, I've got this demo Dapp that I've built for this session. I'm going to go ahead and connect my wallet. Okay, once your wallet is connected, sorry, just 1 second. I seem to be having some trouble with my images loading. Okay, I think that's the problem. Start up the application. So what we're going to be covering today, guys, is we're going to be working with the Xend Finance SDK. I think that the link is up in the comment section. We're basically going to go through using the Xend Finance Web SDK to be able to achieve depositing into the layer 2 protocol, as well as withdrawing from the layer 2 protocol. I'm also going to take it a step further by being able to show users how to interact with Web3 to get the balance of the assets in their wallet, as well as how to get the balance of their assets deposited into the protocol. So it's quite a bit to cover in the session. I'm going to try to go through it as slow as possible. But by the end of it, I'm fully confident that everyone who's watching this session will be able to do the exact same thing in their dApps. So let's just give it a second to start up, and I will show you exactly what we're covering. Okay, so if think what I will do is I'll jump right into the code immediately. I'll take you through these steps from the front end, right through to the back end, right through to calling the smart contracts, and of course, interacting with the SDK. So I broke it up into a few sections as I've just explained. The first thing is we want to be able to get the user's wallet balance. And by wallet balances, I mean the assets that's currently in their wallets. The second that we want to do is we want to be able to get the balance that's deposited in the protocol itself. And the last two things that we want to do is actually do a deposit and a withdrawal using the SDK. So I think without any more delays, as soon as the project can just start up here, I'll be able to take everyone through exactly what we're going to do. Sorry guys, just give me a second. The app seems to be starting up. Okay, so I think while we wait for the development server to actually come up, let's go ahead and jump right into the code, not to waste any time. The first thing that we want to cover, as I've explained, is being able to get the user's balance of their assets. Now, I think before we go a step further, when we talk about assets, what do we really mean? In this case, we're referring to BUSD, USDC, and USDT on the Matic chain. So the steps that we're going to do is we're going to first of all instantiate our contracts using Web3, as well as then being able to get the balance of our assets and then be able to format the balance that would be displayed in the front end. So there's a couple things that we need to bear in mind. The first things being that when we talk about instantiating a contract with Web3, there's different RPC providers that we would have to use. So in the case of Binance Smart Chain, we need to use the BSC RPC. In the case of Matic, we need to use the Matic Chain RPC. This is the two that I have illustrated up here. And what we're going to do now is we're going to go ahead and instantiate the contracts for these specific assets on these different RPCs. I think while the application is starting, we might as well just dive right into it. The way that one would do this is we would start by, first of all, being able to instantiate these contracts, as I just explained with the RPC. So I think let's jump right into how we would do this with the USDC asset itself. First of all, what we need to do is we need to be able to actually instantiate Web3. How one would do that would be as the following. So we would begin by go ahead and calling Web3. Let's go ahead and do that. So in the case here, you can see I'm using the BSC one. We would then go .eth, .contract. And after that, there are specific parameters that we need to pass in here. As you can see, it's determined by an ABI. Now, what exactly is an ABI? It's something that I want to touch base on. So if we look at this particular asset, USDC, and we go up to BSC scan, let's go ahead and paste that address in. This is indeed the asset that we're talking about. As you can see, it's USDC on the BSC chain. So we want to basically be able to, in our application, have the ability to see the same balance that is in our MetaMask wallet in our Dapp. Just 1 second. I'm not sure why my machine is this slow. Okay, so the assets that I'm referring to is the ones you see here within our wallet. We want to be able to read these balances and display them in our Dapp. So that's the end goal now. And I just start up the application so I can show you guys from the front end. Okay, so I think while we still wait for that, let's jump right in. So the first steps that we'd have to do is we're going to call our ABI manager, which is a component that I have set up. This is then going to reference the ABI. And in this case, we're looking at the USDC, right, which would be this ABI. Now, there's something I want to discuss now is we're actually going to reference it as any array. The reason why I'm illustrating it this way is to be able for the users to understand exactly that an ABI is nothing more than just an array with values inside of it. The second step we need to be able to instantiate our contract is, of course, the address. And in this case, we are interested in the USDC, which is, in fact, this address. With this line of code, we've now instantiated our USDC contract on BSC, which we will then use to be able to retrieve the balance. So the application has started up now, and I just want to go ahead and show the users what do I mean in the front end, what we're trying to achieve. Okay, so we would connect to the Binance Smart Chain. And essentially what we're trying to do is we're trying to display these balances from our wallet in the front end. So let's jump right back into the code. And we've done now what we need to do for the BSC contract. Let's go ahead and do the same thing for the BUSD contract. Okay, and of course we need to then take our BUSD address. And finally, let's do the same thing for Matic. The difference is, of course, as I explained earlier, we're not going to use the Binance Smart Chain RPC, but we're actually going to use the Web3 Matic, which is our Matic RPC. Then going to reference the ABI. In this case would be Matic USDT. And we're going to reference the address for that particular asset. Cool. So now we've basically instantiated the contracts. The next step is to be able to call the balance of method of this. So what I want to do is I just want to pause for 1 second. If we take the BUSD contract as an example, let's go back to BSC scan. What we're essentially trying to do is for this particular asset, we want to call a contract function. And in this case, if we go on contract, we basically want to use the ABI. This is where one would grab the ABI. And if we go to read contract, we're essentially trying to use the balance of method, which is seen over here. So let's go ahead and do that. Let's start with the BUSD. Okay, so the next step is we now want to be able to call the contract itself. So let's go ahead and await it. And then let's use our BUSD contract. Right, let's go ahead and call .methods. And then let's go ahead and call the balance of function as I've just shown you now in the smart chain. Let's go ahead and pass through the address, the user's address. And because this is a read-only function from the contract, we can go ahead and call. Cool. That's going to give us our balance of our BUSD in our wallet. Bear in mind that this is still not formatted in the fashion that we need it to be. Let's go ahead and continue the rest with the others. So let's look at the Matic. We're again going to do the same thing. We're going to await our contract. So we're going to use our Matic contract. For methods, balance of. Going to pass through the address. And we're going to call the .call. Cool. That's going to give us our balance of our Matic, in this case USDT. And the final thing that we want to do now is do the same thing for our USDT. Okay. So in this case, we're going to use our USDC contract. But methods, but balance of, and the address. Cool. That should then give us our balance that's in our wallet. The last step with this particular section is we actually need to format this balance. Now, what do I mean by format this balance? Let's go ahead and look at the BUSD one. So in this case, we need to take the value that was returned, right, which is in this case the balance BUSD, and we need to then use our Web3. So we've got our Web3.utils .from where, and in this particular function, we want to pass through our balance BUSD. Okay, we want to .toString it. And we then want to pass the way that we want to format this balance. Now, in this particular case, it will be Ether. So how do we know this, or where do we get this value from? How do we know that? I think before showing you the smart contract, let's actually go ahead and look at the Matic section. So if we look at the Matic USDT balance, you'll notice a difference. First of all, we're going to use our Web3 Matic. Okay, we're going to call .utils. Again, from where. In this case, we're going to pass through the balance that we got from our contract on the Matic. .toString. And the last step is to then pass in this value, which is actually M-way. So the difference is that we want to format the balance we receive back here to 8 decimals, and we want to format the balance we receive here to 18. So how do we know that? If we go back to our contracts, again, contract, read contract, you can see the decimal values. This is how we know what the value that should be returned, the amount of decimals that should be returned. So as you can see in BUSD, it's 18. Ether is 18 zeros after the number, whereas M-way is 8 zeros after the number. So let's just go back and finalize this last one we've got left here, which is USDC. Okay. Cool. So the last thing we need to do is pass in the USDC balance that we receive back. And as you can see, it's again Ether because it's the decimals to the power of 18. So we can confirm that by taking the token. Let's go to the contract on chain. Let's go to contract. Let's go to reader's proxy in this case, because it's a proxy implementation. And let's look at our decimals. It's 18, which is even though it's a stable coin, it's different to what we see on Binance on Matic, which is indeed 8 decimals. So with that, I think we were able to successfully grab our balance from our wallet. The last thing we need to do is let's actually add these values in over here. Let's add our USDC and let's add our BUSD. Cool. This will be wrapped up in an object, which we will return to the action, which in this case is this action, and we will then dispatch it to the front end. So let's go ahead and save this, and let's see what we have on the front end. So we're back here. Let's go ahead and refresh. And another thing that we can do as well is, while we're looking at the front end, remember we've dispatched to the Redux store. And in this particular case, we can actually see that value's been dispatched to the Redux store. So if we go to console, we go to Redux, we have a look at our reducer, and in this case, it's the user wallet info. Okay. If we expand this, you can actually see we've dispatched the balances. So that is how you get the balances from a user's wallet to be displayed in the front end. I think that's pretty cool. The next step that we want to do now is we want to be able to actually get the user balance that is currently in the layer 2 protocol. So let's go ahead and jump into that, and I can take the users through that. So again, we've got the same flow or structure that I personally have followed. In this case, I always like to have an action followed by a method. So let's go ahead and look at our get user balance in protocol. Again, we dispatch in the action, call in the method. And what we want to do here now is we want to be able to call the protocol and see what is the user's balance in the layer 2 protocol. So that after, when we use the SDK to do a deposit or withdrawal, we'll be able to actually see the balance that the user has currently invested in the layer 2 protocol. So this is a bit more in depth, but I think let's jump right into it. The first thing that we want to do is we need to look at the protocol addresses. So if we take example, the USDC, which in this case is the X order protocol on BSC, we can go ahead and look at the contract itself. Okay, so you can see USDC. If we go to the contract itself, you'll notice that this is actually a proxy implementation. So we would grab the ABI, which would be located over here. And we essentially want to interact with these functions to be able to get the user's current balance invested in the protocol. So let's go ahead and do that. The first step we want to do, I think, let's tackle it one by one. We'll start with the BUSD BSC. We want to create a function that's essentially reusable in this case. So what we can do is I've created this function where we can pass in the ABI, and we can pass in the address of the protocol itself and the user's address. So the first step that we want to do in this case is, again, we want to instantiate our Web3 contract so that we can interact with it. So how do we do that? Pretty much exactly the same as we've done before. Let's go ahead and do that. So we're going to call our contract. Okay, we want a new Web3. .eth, .contract, capital C. Okay, we then want to pass in the ABI, and we want to have the address of the protocol. Cool, pretty straightforward. We've got our contract. The next thing is we want to get the balance of the user invested in the contract. There is calculation, which I will explain later. But in this case, let's go and get the balance. And again, we're going to await our contract. Okay, and we're going to call methods. And we want to call a particular function, in this case called get price per full share. Okay, cool. Okay, the next thing that we want to do now in this case is, one last step before that is in the balance itself, we actually want to call balance of. We're going to use this in the next line. So we'll go balance and then balance of. Okay, and we want to pass in the user's address. Okay, once we have that, the next thing we need to calculate is the price per full share, which is done like this, using the same contract, get price per full share. And the final step in being able to get the balance is we need to perform a calculation. And I want to show you that calculation quick. Okay, so we want to call amount. And in this particular case, what we want to do is we want to convert it to a number firstly, the price per full share. Okay, once we have that, we then want to times by the balance that the user has. Okay, once we've got that, we then want to divide it by the number, which is a big int. Actually to the exponential of 1 to the power of 36. Reason being that this returns a number that is to the power of 18. To the power of 18, meaning 18 plus 18 is 36. We need to divide it. And we then want to call .toLocal string. Right, the reason why we're actually calling this is with JavaScript, what happens is if a number is too big, it becomes an exponential number, which will return something like this as illustrated on the screen. So JavaScript automatically makes it an exponential number after a certain length. That is essentially why we are doing this. Okay, next step is we then want to call this, which is exactly as I explained before. Okay, and the last step is to be able to then use the grouping. In this particular case, it will be false. Okay. And then just want to make sure I'm using a bracket. That's all we need for our calculation. We now have the amount, which we're going to call to 2fixed. Basically just formats it to 2 decimal places. And this essentially will give us the XAuto user balance. So any amount that's been deposited into the protocol using the XAuto, we'd be able to then see the balance over here. So let's just go ahead and finish up the rest, and we can go ahead and see how that looks on the front end. So for the X Vault, it's exactly the same. So I'm just going to go ahead and comment that out. However, for the Matic, it's slightly different. It's almost simpler. All we have to do is call the balance of. There's no calculation, and that will essentially give us the balance that we can display in the front end. So with that being said, let's go ahead and comment this out. So we're not going to use it anymore. Let's go ahead and uncomment the calls to the new methods we've just written. And then this, once again, will be dispatched in an action and essentially should give us the balance that a user has staked in the protocol. So I've already been interacting with the protocol. So let's go ahead and just refresh. And there we go. You can see the balances that we have currently staked in the XAuto protocol, X Vault, and the XAuto Matic. So the final step now really is to showcase to the users exactly how easy it is, given all the tasks that we've currently done, to be able to interact with the SDK, to be able to deposit into these protocols. So before doing that, I think I should bring up the documentation. Okay, which we can see here. It's very well documented, very easy to use. And in this particular case, what we're going to do is we're going to use yarn add, and we're going to add our SDK. Then we're going to jump back into the code, and I'm going to show you how to utilize the SDK. Let's go ahead and just stop the application. And let's go ahead and add the SDK. Cool. And with that, we're going to go ahead and grab the SDK from npm, install it in our project. Once it's been installed, you can always confirm that it has indeed been installed by having a look at the package.json. And you will see that it will be added here once it's complete. So let's just give it a second. Okay. So I think while we're waiting for that, I think let me just jump into the front end. The screen that you see is this particular screen called Home. What I have is a pretty simple UI. The differences, or the things that I'm doing really, is being able to firstly have a drop down to select the protocol that we want. In this case, USDC on XAuto for the BSC, USDT XAuto for Matic, BUSD XVault for BSC. Once those options are selected, I then save it using the use state, and I'm then dispatching an action for deposit and withdraw. The deposit and the withdrawal action essentially itself is going to hit this section where we're going to call the action that was created. Once the action is created, the next step really, given my sort of flow design, is from the action to then be able to call the deposit method. And it's in here that we will then begin to utilize the SDK and actually allow users to deposit into the protocol. So let's just confirm that this is done. Awesome, so it's finished. Let's go back down to our package.json. And we should indeed see it right here. Okay, so I think we're pretty much ready to go now. Let's jump right back into the code. So let's start with the deposit. And in the deposit, when utilizing the SDK, as per the documentation, the first thing is, of course, we need to install the SDK. And after that, we need to be able to then instantiate the SDK, which I have on top here. So all we do is we import XF from Xend Finance Web SDK. We're then able to use this object within our project. So in this case, we're going to pass through the protocol, whether it's XAuto, XVault. We're going to allow the users to then do a deposit. So I think let's start with the XAuto deposit, and we can work our way through it. So it's pretty straightforward. It's a very easy to use the SDK. And I think the best way to explain it is, firstly, there are a few parts that need to be added in order for you to instantiate the functions within the SDK. What I want to do is, I'm going to go ahead and type it out. Actually, I think it would be easier if I explain it step by step. So as we're saying, we want to use the XAuto protocol. So let's go ahead and do that. And then what we need to do is we need to be able to then await the SDK's functions, which we've said is XF. And we want to pass through the chain ID, so either 56 or 137. We also want to grab the private key, which in this case, I'm actually grabbing from the env file. And the last step is we want to be able to call env, and we are interacting on mainnet. So this is real funds, it's not testnet. Okay, and I think that looks good. Cool, that's how we instantiate the Xorder protocol using the SDK. The next step, of course, now is to be able to actually use this. So the first thing we want to do is let's call approval, because in order to spend one's assets, you have to first approve it, and then you'll be able to use the functions like deposit. So let's await Xauto dot approve, and we want to pass in the asset, and of course we want to then pass in the actual amount, which in this case we've got a variable called deposit amount. Okay, when the approval happens, I think just for reference sake, let's actually just log the approval so we can see it. When the approval comes back, we need to look at the transaction response that we get, and we need to first confirm that it's indeed successful. So how we do that is, this will be the response we get back from the deposit, but we then want to have an if statement that says if the approval, if there is actually an approval object that comes back, as well as the approval status has to be true, then we know we're good to go to move to the next step of the logic, which in this particular case is actually the deposit. So let's do that in our response here, where we're going to call, again, we're going to await the protocol coming from the SDK, and we are going to call the deposit function. Okay, so in this particular function, we need to pass the asset, which would be USDT, BUSD dependent, and then we want to go ahead and put the deposit amount. This will essentially then call the deposit on the protocol itself and deposit our funds into the Xorder Layer 2 protocol. The final step, I guess, after this would be to return the response. Cool. So that is basically how we would be able to deposit our funds into Xorder. There is an approval and there is a deposit section. We can go ahead now, and I think let's just wire up the X Vault while we are here, and then we can actually just test all the scenarios from the front end. So for the X Vault, it's pretty much exactly the same. The only difference is, of course, when utilizing the SDK, we're not interested in the Xauto protocol, but we're actually interested in the X Vault. Okay, same approve, same deposit, and we return the response. So that essentially should allow us to be able to deposit into the Xauto and X Vault protocol using the SDK. Awesome. Let's go ahead and restart up our project. I think while we're waiting for that to start up, let's go ahead and look at some more front end. The best way, really, it's a structure that you could follow, is of course when you dispatch a particular action, a method that one could use would be to, after the action is successful, to then go ahead and dispatch an action which could essentially update values so that it could be instantly seen in the front end. How one would do that is, of course, using something like a use effect. You could listen for changes. And once you use something like a use effect to listen for changes, or you decide to use the selector, which you grab from your Redux store, you can then utilize these values depending on how you set them up, essentially in your HTML section, which you could see in this case. We are using over here. So if I could just make this a bit bigger, this is the balancing protocol object, and it will have essentially the values that we need. We can confirm this by looking at something like the Redux store. If we look at the reducer, we can then see that user wallet info in another case is what we would use, but in this case, the balance in the protocol, and we can see the values over there. That's just a very neat way for you to instantly update the values on the front end. The next step is we're going to actually do a deposit as soon as the project starts up. Sorry guys, please bear with me. My machine is a little bit slow. Okay, so I think for the sake of not wasting time, we've covered the deposit section. Let's go ahead and jump right into the withdrawal section, again, utilizing the SDK. So it is very much the same. The only difference is the way that we utilize the SDK. So once again, I've got the withdrawal section. And of course, depending on the protocol, we're then going to call the different withdrawal functions on the different protocol. So how this is done is exactly the same really to how we would do a deposit. The difference is we need to, instead of calling a deposit function, we need to call a withdrawal function. So how we would do that is, I think I could just grab it from here. Of course, we need to first instantiate the SDK, or the function in the SDK that we want to use, or the protocol. Once we've got that, don't forget guys to import SDK. Once we have that, essentially what we want to do at this point is go ahead and just add a response. Okay, and let's use this response by waiting with the dot withdraw. So not deposit, but withdraw. We want to add the asset. And of course, we want to add the withdrawal amount in this case. And that's pretty much it. That's how simple it is to do withdrawal. So let's go ahead and return the response. Okay, so exactly the same for Xvault. The only difference is we're not using the Xauthor protocol, the Xvault. That's it. We've got with deposit and withdraw, and we should be good to go. Just waiting for the project to start up, which I think is almost done. There we go. Okay, so I think let's go ahead and test this out. Let's go ahead and select USDC. You can see my balance is 79. Let's go ahead and add a 4 USDC into the Xauthor protocol. And let's go ahead and hit deposit. Let's bring up the console log. Okay, so we've got the response we can see here. If we open it up, we can actually see the transaction. We can confirm this by, let's go into the transaction hash. Go back to BSC scan, double quotes. Boom, you can see the transaction. Pretty cool, pretty straightforward. And let's just go ahead and continue. And we can see the balances instantly updating. Fantastic. Let's go ahead and do the same thing, but with withdrawal. And let's hit withdrawal. Okay, let's just have a look at this. Okay. Okay. Okay, cool. I didn't save it. Let's go ahead and refresh. Wallet's still connected. Balance is still showing. USDC. Let's go ahead and withdraw 4. So again, go ahead and look at the console. So there we go. Done. And the withdrawal function is complete. So there's one last thing I would like to show everybody. And, as you've seen, there was some user interaction of basically showing some sort of loader. I believe you could enhance the experience by, taking it a step further. A way that I would personally do that is, being able to show the user some sort of responsive notification. So essentially like a notification engine, if that makes sense. I think a way that you would be able to do that is if we go back to our deposit function, deposit or withdrawal, depending on wherever you want to use it. We know we've got an approval here in this case. So let's go ahead and actually add this, which is basically creating a notification pointing to that transaction hash. Let's go ahead and save it. And what we're expecting to see now is a pretty neat notification at the bottom, which allows us to click and essentially open up the transaction in BSC scan. So I think let's go ahead and test that. Bear in mind, we're only looking at the approval transaction hash in this case, and you would probably like to present the approve and deposit transaction to the users. So let's go ahead and select the USDC. 5. Okay. So once the SDK comes back with a response, we're essentially expecting to see that in the form of a notification, boom, which we've just seen. If we click on this, so it will essentially open up the transaction in BSC scan. I think that's a really cool way to present things to the user in the front end. It's something that we at Xend use all the time. And yeah, I think that pretty much covers all the sections, guys. If there's anything else that I've left out, feel free to contact me. And yeah, welcome to the Xend team.
All right. Thank you so much. Thank you so much, Kashif. Thank you for that section. Thank you for that. Thank you for that section for explaining to us how to integrate Xend Finance SDK and the Layer 2 protocol into your Dapp I mean, this is a actually recorded session, so in case you missed any session or any part, so you can just go ahead and just go back and check. So thank you so much. Also, just to remind everyone that we are giving away $300 to the first project that is going to integrate the SDK or the L2 protocol into their platform. So, I mean, you could just go over this session. You can ask Kashif. I don't know if you want to share your Twitter handle or something. Yeah, you can just contact Kashif or ask any question, and he'll be right there to to answer you.
Cool. Should I just drop it in the comments or?
Sure. You can go ahead and
I'm,
drop it in the session.
I'm already active on Twitter, so should I drop my LinkedIn profile?
Oh, yeah, your LinkedIn. Okay, fine, cool. Your
Okay,
LinkedIn profile
cool.
will do. Yeah.
Let me just go ahead and do that. Okay, so let me just drop it in here. I dropped it in the private chat. Ushe, could you maybe just copy it into the comment section?
Okay. All right, cool. Just do that. All right, so you can contact Kashif through the link on in the comments section if you have any question trying to integrate the Xend Finance L2 protocol into your platform. Yeah, I think that's a wrap. So thank you so much, Kasif.
Cool. Pleasure, man.
I mean, we'll be coming on consistently for other sessions. So thank you so much. Thank you so much for the session. Thank you guys for joining us. And like I said, you can also go back on this session and every part, and it's a recorded section. It's on Xend Finance YouTube channel, so you can go over this session just in case you are integrating the SDK, the Xend Finance SDK, into your Dapp. So thank you so much for joining us, guys. Thank you, and thank you, Kashif. I think we'll see you in the next one. Thank you.
Thanks, guys. Awesome, man. Cheers, Bye.
Yes, see you. Yeah, bye.